The smallest aluminum wire gauge permitted for connection to a circuit breaker in an electrical panel is number 14 American wire gauge, or AUG. Understanding wire sizing is crucial for safe and compliant electrical installations. Aluminum wire is commonly used in electrical systems, particularly for larger conductors, due to its cost-effectiveness and lighter weight compared to copper. However, its application with smaller gauge wires requires careful consideration. The National Electrical Code, or NEC, sets standards for wire sizes and their corresponding ampacities to ensure electrical safety and prevent overheating, which could lead to fires. Number 14 AWG aluminum wire has a limited ampacity, meaning it can only safely carry a certain amount of current. This ampacity is typically lower than that of a similarly sized copper wire. The ampacity of a conductor is determined by several factors, including the wire's material, insulation type, and the ambient temperature in which it operates. When using aluminum wire, it is essential to consult the NEC tables to determine the correct ampacity for the specific installation conditions. Aluminum wire also has different properties than copper wire, including a higher resistance and a greater tendency to oxidize. Because of this, aluminum wire requires special handling and termination techniques to ensure a reliable and safe connection. When terminating aluminum wire to a circuit breaker, it is crucial to use connectors and terminals that are specifically rated for use with aluminum conductors. These connectors are designed to provide a secure and corrosion-resistant connection, preventing the formation of oxides that can increase resistance and cause overheating. Antioxidant compounds are often used to further protect the connection. These compounds prevent oxidation and maintain a good electrical contact between the wire and the terminal. Another important consideration when using aluminum wire is its tendency to expand and contract more than copper with changes in temperature. This thermal expansion can loosen connections over time, leading to increased resistance and potential overheating. To mitigate this issue, it is important to use properly sized connectors and to periodically inspect and tighten connections as needed. In residential wiring, aluminum wire is typically used for larger branch circuits such as those serving electric ranges, water heaters, and air conditioners. It is less common for smaller circuits, such as those for lighting and general-purpose outlets, where copper wire is often preferred. This is because the smaller gauge aluminum wires are more susceptible to damage and require more careful handling. When working with aluminum wire, it is important to follow all applicable electrical codes and safety standards. This includes using the correct wire size, proper termination techniques, and appropriate overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overloads and short circuits. These devices interrupt the flow of current when it exceeds the wire's ampacity, preventing overheating and potential fires. The size of the overcurrent protection device must be carefully matched to the ampacity of the wire. Using an overcurrent protection device that is too large can allow the wire to overheat, while using one that is too small can cause nuisance tripping. It is also important to ensure that the circuit breaker is properly rated for use with aluminum wire. Some circuit breakers are specifically designed for use with aluminum conductors, while others are not. Using a circuit breaker that is not rated for aluminum wire can lead to corrosion and connection failures. When installing aluminum wire, it is important to strip the insulation carefully to avoid nicking or damaging the conductor. Nicks and scratches can weaken the wire and increase its resistance. It is also important to clean the wire thoroughly to remove any dirt or debris. After stripping the insulation, the wire should be immediately terminated to prevent oxidation. If the wire cannot be terminated immediately, it should be protected with an antioxidant compound. When connecting aluminum wire to a terminal, it is important to apply the correct torque to the screw or bolt. Over-tightening can damage the wire or the terminal, while under-tightening can result in a loose connection. The correct torque specification is typically provided by the manufacturer of the connector or terminal. Periodic inspections are essential for maintaining the safety and reliability of aluminum wire connections. During these inspections, it is important to check for signs of corrosion, overheating, or loose connections. If any problems are found, they should be corrected immediately. In some cases, it may be necessary to replace the entire connection. When replacing aluminum wire connections, it is important to use the same type of connector or terminal that was originally installed. Mixing different types of connectors can lead to galvanic corrosion, which can weaken the connection and cause it to fail. In summary, number 14 AWG is the smallest aluminum wire size, following electrical codes meticulously, using appropriate connectors and antioxidant compounds, tightening connections to the specified torque, and conducting regular inspections for safety and reliability, all contribute to a safe electrical system. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Proper wire sizing is crucial for maintaining a safe and reliable electrical system. Always refer to the National Electrical Code, or NEC, and local regulations for specific requirements and guidelines. When in doubt, consult with a qualified electrician. They can assess the specific conditions of your installation and provide recommendations for the appropriate wire sizes and termination methods. Understanding the properties and requirements of aluminum wire is essential for ensuring a safe and compliant electrical installation. By following best practices and adhering to the NEC, you can minimize the risk of electrical hazards and maintain a reliable electrical system. Remember that electrical codes and regulations can vary depending on the location. It is important to check with your local building department or electrical inspector to ensure that your installation complies with all applicable requirements. Using the correct wire size and termination techniques is just one aspect of electrical safety. It is also important to ensure that all electrical equipment is properly grounded and that ground fault circuit interrupters, or GFCIs, are installed in areas where there is a risk of electric shock. GFCIs are designed to protect people from electrical shock by quickly interrupting the flow of current when a ground fault is detected. They are typically required in bathrooms, kitchens, and outdoor areas. Regular maintenance is also important for maintaining the safety of your electrical system. This includes checking for frayed wires, damaged outlets, and other potential hazards. If you notice any problems, they should be corrected immediately. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. They have the knowledge and experience to safely and effectively perform electrical work. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. By following these guidelines, you can help ensure that your electrical system is safe and reliable. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. The NEC covers a wide range of topics, including wire sizing, overcurrent protection, grounding, and wiring methods. It is essential for electricians and other electrical professionals to stay up to date with the latest edition of the NEC. The NEC is not a law, but it is widely adopted by state and local government. In many jurisdictions, electrical installations must comply with the NEC to be considered safe and legal. The NEC is a valuable resource for anyone who wants to learn more about electrical safety. It provides detailed information on how to properly install and maintain electrical systems. There are also many training programs and educational resources available to help people understand and comply with the NEC. Understanding the NEC is essential for ensuring a safe and compliant electrical installation. By following the guidelines in the NEC, you can minimize the risk of electrical hazards and maintain a reliable electrical system. In addition to the NEC, there are also other standards and regulations that may apply to electrical installations. These include standards from organizations such as Underwriters Laboratories, or ALL, and the Institute of Electrical and Electronics Engineers, or IEE. It is important to be aware of all applicable standards and regulations when working with electricity. Compliance with these standards and regulations is essential for ensuring a safe and compliant electrical installation. By following best practices and adhering to all applicable requirements, you can minimize the risk of electrical hazards and maintain a reliable electrical system. In conclusion, using the appropriate size and type of wire is crucial for electrical safety. Consulting with a qualified electrician and adhering to the National Electrical Code are essential steps in ensuring a safe and reliable electrical system.